Hello, AP Stat students. This is your last video lesson. I will turn in grades by next Monday. So this is it. This is your last grade that I will actually calculate. I will fill in most of the grades this week. That way you can see where you are and do anything that's missing. Here we go. Let's go for it. Okay. A random variable, a numerical variable whose value depends on the outcome of a chance experiment. So just rolling like rolling a die. A rolling a die, each outcome is chance. It has a probability of happening. That's really what a random variable is. Two types, there's discrete and continuous. So discrete is something that's countable, so the outcomes are countable. So obviously the die that you roll is discrete because you have countable choices, 1, 2, 3, 4. Versus continuous is like measurement. So when I want to know what's the likelihood of somebody being 5 feet tall, and it goes with a normal distribution, that's continuous. All right, so a probability distribution just gives all the possible outcomes. So when I roll a die, it's 6 possible outcomes. It will list it, and you can display it on a table. And under that, the outcomes, you'll show the probability of happening. Now, for every possible value of your outcome, probabilities have to be no less than 0 and no bigger than 1. So you know probabilities have to be between 0 and 1. And remember, all the possible outcomes, probabilities of happening needs to be 1, represents 100% of what could happen. All right, so here we go. Here's our example. So example number 1, let X be the number of courses for which a random selected student at a certain university is registered. That's a probability distribution table. We're saying that people can register for a minimum of 1 classes to the most 7 in a semester. Suggestions for you guys going out to college, please don't do more than 4 or 5. This is actually really close to what people would have taken. I did 4 in my first semester just so I could get used to 4 courses. All right, so here we go. We're missing 4. 4 doesn't have a probability on it. So remember I said that all of the probability outcomes has to add up to 1. So when I look here, that needs to equal to 1. Right now, it doesn't. Right now, if you add these up, they add to 0.75. So the 4 courses probability has to be the leftover. So I do 1 minus 1.75. I get that as 0.25. So for my first one, it's asking me what's the probability that the number of courses that a student takes is equal to 4. Well, that's easy, it's 0.25. And from there, I'm just going to read and add or do whatever I need to answer the question. So it says, what is the probability that the number of courses is less than 4? So less than 4 would be to add those up. And that looks like that's 14, if I'm correct. All right, so then this one says, what's the probability of the number of courses being less than or equal to 4? The difference here, I need to include the 4. Let's choose a different color. So to get that, I have to add the 14 and the 25. And so I get 39. So now it won't be that easy. They normally tell you in like sentences. What is the probability that the student is registered for at least 5 courses? So at least 5. So at least is like a minimum. So a minimum of 5 courses or more. So here I need to add those probabilities. And so at least is represented as greater than or equal to 5. And so that's the answer to that one. So that's pretty simple. So now let's think about formulas I can use off the thing. So here we have is the average on a probability distribution and the variance, which if I take the square root of that, it would be a standard deviation. Now, since of what's happening right now, odds are you're not going to have to use that formula at all. It takes too much math. This formula, the mean formula, is really easy to use. So that's what we're going to focus on in our next example. Formulas are found on the formula chart, but when you get the context of this, you'll see. So in our next example, how to use a formula for mean, also called the expected value. So here I'm just doing an example. The easiest way to see it is to understand weighted averages, how I would or your systems calculate your grade average. It calculates by a weight. So if I know that the weights or the percentages of each category, and I know how much you guys made on the test, I have your grades, then what we do is this, for example, would have represented X, and this would represent the probability of X, because that's basically what it is. So how I do it is to get your grade average, I take the grade that you have for that category and multiply it by its percentage. And I do it so on, so on, and so on. I add them together, and that's how I get your grade. It's going to be the same thing you do. That's where the X falls in. That's X, that's P. And summation means to do it for each category. So that's how you understand the formula. So if I move on, let's actually do it with our number of courses. So it says, what is the mean or the expected number of courses for registered students? And remember that word expected number of courses means to find the average. So again, I'm going to do the exact same thing. I'm going to write mean out, and I'm going to take each scenario and multiply it by its probability and add it up. Hence, which is why if you have to do this formula, you can easily do it on a calculator. So it could be something that could show up on a free response. It's not that hard. So when we get that, so the expected number of courses for a registered student is 4.66. So there you go, which makes sense because the majority of the students fall here. So I would think that, yeah, that makes sense. Most of the students are taking between 4 and 5 courses. All right, so moving on. Okay, so here we have a list of all the possible ways that when you roll 2 die, what could happen. Okay, and so when you roll 2 dice, one die has 6 outcomes, another die has 6 outcomes. So 6 times 6 is 36. This gives you all your possible choices that could happen when you roll 2 die. And if you notice something, I see 2, 1 right here. So here's 2, 1. And then there's a 1, 2. And so all the combinations, if you have a 3, 1, you could have a 1, 3. It's because that the left die that you have, or your red die, could be 2, and the white die could be 1, and scenario it flip-flops. And that's how you have your total of 36. Now there is the diagonal one. The doubles will not have a double because red is 1 and white is 1, and there's no way you can change that. So they don't have their own doubles. So anyway, that's all your possible combinations. So dice questions come up all the time. So just make sure you understand and know what your combinations are kind of in your head. All right, so here we're going to talk about why does Vegas, because they pay out money, how do they make their money? So this is how they make it. So we're going to go deep in Vegas, and we're going to look at a game, a possible hypothetical game that can happen. All right, so in a game, if a player rolls 2 dice and gets a sum of 2 or 12, he wins $20. If he gets a 7, he wins $5. The cost to roll the dice one time is $3. Is this game fair? Well, in statistics or in probability, a fair game is one where the cost to play equals your expected value, or the average of the game. So we need to find what is the average or the expected winnings that could come out on average for players. So we're going to make a probability distribution table. So X is going to represent our winnings, and then so the probability of the winnings is what we need to figure out. So first of all, how much could you win? You could win the top prize, which is $20. Well, how do you win at $20? Well, let's look at it says you could have to roll a 2 or a 12. Well, 1, 1 and 6, 6 are in the corners. So that's only 2 times. There's only 2 times that you can do that. So hence, there's 2 out of 36 chances to get to 20. All right, so we got that. Well, what's the next thing you win? You can win $5, but how do you win the 5? By rolling a 7. So let's see all the possible ways for 7 to happen. So if you look at your sheet, you could have, what do we have? We have a 1, 6. So we have a 1, 6 down here. So therefore, we got to have a 6, 1. So that's a 6, 1. That's a 1, 6. And so let's get 2, 5. 2, 5, 2. 4, 3, 3, 4. So we have 6 combinations for getting a 7. All right. So now let me erase that. Okay. So now that's 6 combinations. So let's go ahead and write that. Now, to lose, we're not going to count the rest of the ways to lose. We're going to use common sense and just subtract the winnings from the loss because all the other combinations are losing combinations. So we're going to do 0 and do 28 out of 36. So there we go. We have our probability distribution table. So let's go ahead and calculate our expected winnings and see if this game is fair. And after this is where I'm going to end the video, and then I'll pick up on example 3 and 4. So 0 times 28 over 6, which yes is 0. Is there a point to write that? No, it's not, but I didn't want to confuse anybody. So you multiply that out and you get $1.94. So on average, your winnings is $1.94. That's not how much you pay for it. And so think about it this way. If you look at the table itself, if somebody played 36 times, 8 times, I have to pay you out. But the other 28 times, I get to keep the money because you're going to be a loss. And that's how Vegas wins. So if I average out that 20 and that 5, the 8 times I have to pay for it per game, I'm paying out $1.94. But if I subtract that from the $3, I'm keeping $1.06 per game. So how Vegas wins is all the people who lose versus the big payouts that they have. So no, the game is not fair since the average expected values of their win is $1.94, which is less to play for $3. So we're going to stop the video right here because that was example number 2. And then we're going to pick up on example 3 and 4, which will be short. It shouldn't be more than 6 minutes. I'll talk to you in the next video.